questions. We'll take one by one to both of you, or like anybody can give the answer, both of you. How can simulation help teams test different materials, wall systems, or roof options before construction begins?
So I'll take this one. Yeah.
Yeah, yeah.
I think when you are analyzing, for example, roof materials like roof insulation, I think the
Mm-hmm.
simulation software can help you determine what kind of a roof material, what thickness of the roof material you can use, and how much
Mm-hmm.
impact that material has on the building performance. You can analyze those
Mm-hmm.
aspects, not even terms of energy performance, but also in thermal comfort.
Mm-hmm.
What's the impact and what is the real base energy impact on the systems and on the building performance as well. So all that aspects you can analyze in a building energy software. Also, if you're doing a comparison of different materials, that also you can analyze in a building energy simulation software, which helps you to determine for which material would be correct and optimized to use in my building for the correct performance. I think
Mm-hmm.
that helps you in a way to select the different materials or systems which goes in different categories. So I think this helps you to understand it more accurately and
Okay, so
ultimately helps you to decide as well, like what material needs to be selected.
okay, so you are saying that you can definitely test different materials like roof, wall, etc., glazing. Also, I think glazing also can be tested, and based on that, you can predict what will be the energy consumption and thermal comfort in the building, and then you can test different material and check the energy consumption and thermal comfort parameter. But have you also checked any point of time embodied carbon and the cost of the material? So, or just you are checking only energy and thermal comfort?
I think this is something which have come up personally. I haven't never initially done it, but now the demand is, I think, changing. I think now people are much more oriented on the emission as well. So we have now started working on the emissions part as well, like how the emissions of a certain material or a certain insulation material or a certain concrete, if you are designing a high thermal mass in a building and you are pouring in a lot of concrete inside the building, then how the emissions, embodied emissions of the building uh, are coming up basically. So now an holistic approach has been taken up, but I think I can say it like in 3-4 years back or 4-5 years back, this was not the case in the industry. We were like focused on how the particular equipment or a particular material is impacting on the building
Mm-hmm.
performance. So
Mm-hmm.
now, but obviously these emissions, these materials have an impact on the emissions as well. So I think those emissions check also needs to be carefully examined while selecting the material, taking a holistic approach, not only on a performance but also on a emission friendly. Uh, we need to check now. So now we are also doing a bit more detailed analysis on these part as well now. But initially
Mm-hmm.
we were not doing it. To be very frank, we were not doing these analysis on like how the emissions of a certain materials would be.
So let's move to the next question. How does simulation help predict thermal comfort and HVAC performance? And how close are simulation results to real world building performance? Aryan, would you like to go for this?
Yeah, I can go with this. So, energy simulation softwares can help us predict the thermal performance. So, we can get result outputs like the indoor air temperatures, the operative temperatures, the heating and cooling loads, and the air conditioning performance, and the sizing of the HVAC systems. All of these are interlinked together and help us decide an efficient system without compromising on the thermal comfort. They also use certain various metrics and various models, thermal comfort models, like India model for adaptive comfort for specific to India, ASHE 55 could be specific to US, and so on and so forth. So
Mm-hmm.
whichever, depending on the model you are using, thermal comfort model, you will
Mm-hmm.
get, of course, different results. But then again, coming to the second point, it is energy modeling is just a prediction tool. So
Mm,
we are predicting that so and so many people would be comfortable within this range of temperature at that particular time, at that particular part of the country, at that particular uh, region. So that is what we are trying to simulate and predict. And on-site conditions can vary, and thermal comfort is also something which varies per person to person. So it is impossible to achieve 100% thermal comfort for everyone, but we can get close to majority of the people and achieving a thermal comfort which is comfortable to most of the people. Basically, saying that if 24 degrees Celsius is the set point you are setting your AC,
mhm,
person sitting near the window could feel little less comfortable, whereas
mhm.
because due to the heat coming directly from the sun, and a person sitting away from the window could be more comfortable or even more cooler because they are sitting away from the window and they have less direct sunlight and thus
Mhm,
less heat. So
mhm.
things like that need to be carefully modeled in your energy simulation software. And if you are careful enough, we can predict the thermal comfort and the proper sizing of the air conditioning systems through energy modeling softwares. But
Okay.
again, you need to know that it may not reflect the real world performance, because in real world, several different scenarios happen. Like people could open windows, the construction quality could be poor, there could be gaps within doors and windows, the
Mhm, mhm.
occupant behavior also differs, the operation of the building could
Okay.
differ, and so on and so forth.
Okay. So on this, I have a couple of questions for you. One, you mentioned the thermal comfort model. I think you mentioned two comfort model. Maybe you can briefly discuss, maybe very briefly. Okay. Second is you meant yeah. Please go and for this, and then I will put another question. You
Okay,
mentioned two
so
model. I make model and another model. Can you
yeah,
briefly tell?
that's ASHRAE 55 thermal comfort standard. So basically, different people in different regions of the world have different uh, thermal comfort bands. Thermal comfort bands are like in India, people might be comfortable with a temperature range of say 24 to maybe 32 degrees Celsius and a relative humidity of let's say 50%. This temperature and humidity range might be comfortable to people in India because they are more accustomed to Indian temperatures. But people in the US may or may not be comfortable with such high temperature range. And
Mhm,
so a different thermal comfort band would be applicable for them. So that
mhm,
would be somewhere like, let's say 20 to 27, 26 degrees Celsius or something like that with certain amount of humidity, let's say 30 or 40%, for example. So that is something we need to keep into mind while simulating the energy performance and the thermal comfort.
Okay.